All right, so I know that last recording stopped suddenly because third period was over and fourth period was starting. So you guys were actually coming in the classroom. So we're going to go ahead and finish up problem 57. So this will be the last problem for unit 3, and then I'll go ahead and give you guys some tips for unit 4. So we were finding the factors for this cubic function right here. And so they gave you the first 2 factors right here. They want you to find the last one. So the last one is going to be one of these factors. You can basically get rid of this one because if it's a cubic function, it's going to have 3 factors. And this right here is a quadratic. So you can't have 2 factors here and then a quadratic. If you were to FOIL that out, that would give you x to the 4th. But we can go ahead and kind of consider it, type it into Desmos, and you can kind of see why it doesn't work. So when we type these into Desmos, we're not going to be typing 2x minus 1. We're going to be typing the other factors, x plus 2 and x minus 1. And then this would be the third factor. For this one, we're going to type the x plus 2, the x minus 1, and then this would be the third factor, 2x minus 5. We're going to type the x plus 2, the x minus 1, and then 2x plus 3 would be the third factor. X plus 2, x minus 1, and then the 2x squared plus 3x plus 12 would be the third factor, which is why we know it can't work, because this would be too much to give you 2x to the 3rd. So I'm going to go ahead and switch over to Desmos. Do that. So I have 2x to the 3rd plus x squared minus 5x plus 2. And then I'm just going to start typing all of these in. And you should be typing them in as well. And I just won't type the last one. Okay, so our original was the red. On the red matches the blue. So it's the first one. You can see it doesn't match the green, doesn't match the purple. So the first answer, F, was the correct answer. So if we go back, 57, the correct answer there was F. Okay, so I believe that was all I was going to do for unit 3 anyway. Let's go ahead and continue on looking at unit 4. So in unit 4, problem 61 is a very interesting problem. And problem 61 is actually taken off of the released EOC from 2018. So it was an actual EOC question. And so this is a really good one to do because you can do this with Desmos, and it's kind of a difficult Desmos strategy that we're actually going to end up doing. So go ahead and start typing that in, that fraction 3x minus 5 over 4x plus 3 plus negative 2x plus 1 over 7x minus 2. Go ahead and pause the video for a moment, start typing that into Desmos, and then I'll tell you how to do the rest of it. So what we're going to do for the second fraction, I'm typing the bottom, is we're actually going to type the a. So I've got ax squared plus bx plus c. And you can see that anytime you use a variable that is not x or y, Desmos gives you the option to make a slider, and we're actually going to do that. So it says add slider, and I'm going to say all. I'm going to say yes, add all of those. So we're going to go through, and you can see in the problem that they say that the A value can be 12, it can be 13, 16, or 29. The B value can be negative 31, negative 33, negative 43, negative 51, and the C value can be those four numbers. So what I'm going to do is I'm going to do this problem by guess and check. Now, if this problem was not written like this, we would have to do the problem a little bit differently. You could do, if it was a multiple choice problem, then this would be a lot easier. So you could still use the slider method, but it would be easier because you'd have less options. So the way this is set up, we've got 4 times 4 times 4, 64 combinations that we can possibly have. But if we keep organized, we're going to be able to figure this out. So the first A value is 12. So I'm going to go ahead and type 12 in here. For B, it's negative 31. So I'm going to type negative 31. And then for C, the first C value is negative 7. Okay. So that answer does not work. So what I'm going to do is I'm going to figure out if I want to circulate through my A's first, or circulate through my B's first, or circulate through my C's. And I'm going to work through my combinations one at a time. So I'm going to go ahead and just go through the C's. So I'm going to leave the A as a 12, and I'm going to leave the B as a negative 31. And I'm just going to try the C. So negative 7 didn't work. Let's try negative 3. That didn't work. Let's try 13. That's kind of close. So let's keep that in mind. Let's see what 16 is. Okay. So 12, negative 31, and then any of the C values did not work. So that means we have to change either the A or the B. So I'm going to leave the A as 12. I'm going to change the B value to negative 33. Okay, and now I'm going to try the C values again. So I'm going to start at the beginning, negative 7. Nope. Negative 3. Nope. 13. Nope. 16. Nope. Okay. So I'm sticking with that first A value of 12. I've tried the first B value with all of the C values. I've tried the second B value with all of the C values. Now I'm going to try the third B value, 43. I'm going to go through all of the C values. Negative 7. Nope. Negative 3. Nope. 13. Ooh, that looks so close. Do you guys see it? That looks so close, but I can still see some black. Okay, let's try 16. Nope. Okay. Oh, that looks so close. Okay, let's try negative 51. I'm going to go through all the C values. All right, negative 7. Nope. Negative 3. Nope. 13. Nope. 16. Nope. Okay, so what just happened is I tried 12 as the A value with all of the B values and all of the C values, and it didn't work. So it means that 12 can't be the A value. But it also means we have worked through a lot of our combinations. So at this point, let me switch the screen. Hold on, let me switch the screen that I'm sharing. At this point, I know for sure 12 cannot be the A value. 12 cannot be it. But I was pretty close. These C values in here got me pretty close, if you guys remember. And then I want to say some of these, because like these B values were getting me pretty close. So with an A value of 12, I was able to get pretty close here and here. So I think an A value of 13 might do it. And some of you guys, if you started ignoring me and started plugging in your own numbers, you probably have even solved it already. So let's try 13 for the A value. And maybe I'll try 33 and like 13 or 16 and just see if we can, or I guess I could keep doing it in organized fashion. So maybe I'll do 13 and negative 31. I'll just keep going organized and we'll see what we get next. Okay, so I'm going to go back to Desmos. I'm going to do the second A value, 13, and I'll just start with the first B value. I'm just going to keep it organized. Okay, so negative 7. Nope. Negative 3. Nope. 13. Nope. 16. Nope. Okay, so that didn't work. So now I'm going to move on to the second B value. Okay, 33. Negative 7. Nope. Negative 7. Negative 3. 13. 16. Nope. Okay. 43. Ooh. 13? Ah. Ooh, I think that might be it, you guys. Okay, so we saw some that got close. We just want to make sure that this is actually it. So what I'm going to do to make sure that it's truly right on there is I'm going to go right up here because sometimes, like if you zoom in, you can kind of tell. Okay, that's probably it. What I'm going to do to make sure that these are really the right points is I'm going to go up here and hit the list button, and we're going to look at this table. And then let's go down here and let's look at this table. Let's make sure they're the same numbers. Oh, look at that, folks. They are. So we just found the solution. 13, negative 43, and 13. That's the answer for that problem. So 13 for A, negative 43 for B, 13 for C. Now, that was a time-consuming process, obviously. If you could remember how to do the problem, just do the problem by hand. But if you don't remember how to do the problem, it's kind of a nice cheater method for doing it. So I do kind of like that method. All right, so that was how you could use sliders to solve a problem. I do want to show you guys another problem where you can use sliders. So we're going to go back to the assignment actually, and we're going to look at problem 71. So if you look at 71, so we had problems where you can solve an equation by graphing them and see where they intersect. But there are problems, especially in this particular unit, so unit 4, where when you graph them, they are so tiny that you can't really see where they intersect. It's really hard to see what the actual answers are. And I don't recall what those problems are, but so this would be another solution method that you could find where things intersect if it's a multiple choice problem like this. So we know from yesterday's lesson that one way to solve this would be to graph 2x plus 5/2 as one equation, graph 3 over x as another equation, see where they cross. You can get the two solutions that way. Another method is to use sliders. So I'm going to show you guys how to do the sliders now. So I'm just going to get rid of these. Let's get rid of these. Okay, so we're just going to choose another variable, 2a plus 5/2. 2a plus 5/2. And then, so there's the slider. And then 3 over a. And so what's happening now is that when I plug a number in for a, it's going to tell me what each of the equations equal. So we're just going to plug in these different numbers, like 3/4 versus 4/3. So if I plug in 3/4, ooh, it equals 4. So we know that that is one of the solutions because it equals the same thing. Let's try. So it was either 3/4 or 4/3. So we know it's 3/4, not 4/3. And then it's either 2 or -2. So let's try plugging in 2. Nope, not 2, it's -2. Okay, so the answers are 3/4 and -2. 3/4 and -2, so the answer is H. So that's how you could use sliders to solve a problem if you are not able to see it from the graph. If you can't graph it and find the intersections, then you could use sliders. So let's go ahead and do this exact same problem, but we'll do it by graphing. Well, there we go. There's the graph. Okay, x equals -2, x equals 3/4. There's the two solutions that way. So that was kind of the method that we had learned from units 1 and 2. Okay, we're gonna hop back in the unit and look at problem 62. So piecewise functions, if you are comfortable looking at piecewise functions on the graphing calculator because you've learned how to graph them there, and that's what you would rather do, that's fine. But you can also graph them on Desmos. So I'm going to go ahead and show you guys how to do that with the limited domain. So we're going to start by typing in -3 divided by x. That was the first function. -3 divided by x. And then we have to type in that limited domain that x is less than or equal to -2. And so the way that you do this on Desmos is you do that little squiggly bracket like that. Sorry, I'm trying to remember this. Yep, okay. And then you, from there, you type x is less than, to get this symbol, you type less than, and then you hit the equal to button, hit equal, and then it will pop in an equal there. So what I typed, let me show you, I'm gonna switch my screen so I can show you exactly what it is that I'm typing here. So I'm typing -3 divided by x. Then I'm typing x is less than or equal to -2. This is what I'm typing. And Desmos is fixing it so that it looks proper. X is less than or equal to -2. All right, so I'll go ahead and finish typing this in Desmos. X is less than or equal to -2. Let's do the next one. 2 to the x -2, squiggly bracket. The squiggly brackets are next to the p, so you're going to do shift and then the number next to the p. X is between -2 and 3. Okay. And this is a little bit easier to type in than it is on your graphing calculator, which is kind of the benefit. And then remember, if you want a square root, you can type, you can hit down here, this show keypad, and then here's your little square root, or you can type SQRT and get the square root that way. So square root x -2. And then we're gonna get our limited domain. X is greater than 3. Okay, so the nice thing about this, when you plug these in, is that yes, we can do this problem where we are just checking to see like, oh, which graph does it match? And I can see that it looks like it matches, I think it matches D the best. Kind of looks like it matches D. Yeah, that's what I think I'm seeing. But you can see like tables of these values if you want. And if you want more values on the table, you can get more values. So this is the blue graph. The blue graph has the negative values. If I want more negatives, I just go up here where I can just start typing the numbers actually, like -5. That's how you get the negative values. -4, -3, -2. Oh, it goes to -1. -1. Well, that was undefined. Must be a hole there. For this one here, we can get this table going. So undefined at -2, and then there's some values goes to, so on the 2, if I click enter, there we go, I can get one more point there, enter one more time, and it's going to be undefined. So there's all the points there. We can go to this one. Let's see the table here. Undefined, undefined, undefined. I want to see the numbers that are bigger than 3. So I'm going to press enter after this and just get some more points. And then once you have the numbers on the tables, you can actually see them on here, which is kind of handy. So for this particular problem, I don't really care so much about seeing the points, although it's kind of nice because now we can see where the holes are. So this point right here is not a hole. This point right here did not show up, so it must be a hole. That point at -2 isn't showing up on the green. So that can kind of help us figure out which one it is. Yeah, so I'm definitely thinking that it looks like D. So that's beneficial. Later on, there are some problems that are piecewise functions where you evaluate the piecewise function. And so it's really nice when you can go through and have these tables in here where you can like see what the numbers are when you plug them in. That's really nice with Desmos for these. So I did want to show you guys how to plug those in so that you would know how to do that. All right, let's jump down to another problem, problem 66. These are not as straightforward to plug in, so I did want to show you this. Okay, so this problem, when you look at it, you have a fraction divided by a fraction, but Desmos doesn't let you plug in this type of division symbol. Desmos only lets you type in division as fractions. So when you type this one in, it says which expression is equivalent. And so when we do this, we're gonna, we're not gonna do math by hand, because why would you if you don't have to? All we have to do is graph the problem and graph the answers and see which one is the same. But when we do this, we're going to have to do a fraction divided by a fraction, which on Desmos is going to look like a fraction divided by a fraction, which is just going to be a lot of lines, like a lot of horizontal lines. So for stuff like this, a nice trick to that is kind of to write it out ahead of time on your paper so that you know what it's going to look like and so the lines won't confuse you. So this is going to be n squared minus 12n plus 36 over n squared plus 3n minus 54. And then it's going to be n squared minus 2n minus 24 over n squared plus 13n plus 36. That's what it's going to look like. So Desmos isn't going to do the keep it, change it, flip it rule. And Desmos is not going to have an extra long fraction like I drew. To make it less confusing, Desmos is going to look literally just like this. So it looks kind of intense when you do it on Desmos. So let's go ahead and start typing that in. So when I type these in on Desmos, when I have a fraction divided by a fraction, and I know it's going to look kind of tricky, what I like to do is type the overall like big fraction first. So I go like, hey, this is my big fraction. Okay, let me go ahead and type like the fraction on the top. So I start like, okay, there's my top fraction. So now I've got, remember Desmos doesn't like n's, it likes x's and y's. So we're going to do x squared minus 12x plus 36 over x squared plus 3x minus 54. Okay, there's my top fraction, and then I'm going to do my bottom fraction. So x squared minus 2x minus 24 over x squared plus 13x plus 36. Okay, and then that's my answer. That's what it looks like. So I can start typing my multiple choice answers now. So x minus 4 over x squared times x minus 10. Oops. Okay. X minus, goodness gracious, x minus 8 over x minus 10, x plus 9. Nope. Now, 1 is the answer for part C. Now, when I just type 1, Desmos is used to being a calculator, so it's like 1, what do you want me to do with 1? Do you want me to add 9 to it? Oh, 1 plus 9 is 10, let me tell you that. 1, do you want me to do 1 divided by 3? 1 divided by 3? Oh, that's 1/3, I'll tell you that. So if you just type a 1 in there, Desmos is not gonna graph it. If you want to graph a 1, you're gonna have to put a y equals in there. So that's kind of the trick about graphing a number, is that you have to put a y equals in there for it to graph the number. Okay, so now I've graphed C, y equals 1. Let's go ahead and do D. X plus 9, x plus 3 over 4x. Okay, so we're looking for the one is a perfectly horizontal line. So not that one. Nope, not that one. Ooh. It is that one. So the answer is C. Right. So that was 66 or 67? 66. So 66, the answer was C. Apparently, when you do that problem, everything cancels out and you are left with 1. Okay, so let's do one last problem. Last problem is 67. So 67, it is an inverse problem, but it's an inverse problem that has to do with rational functions. So I did put it in this unit, but wanted to make sure I covered it. So that inverse notation, I just wanted to remind you guys, inverses have to do with x and y, and the x and the y value trading. So we have a problem here where we have, I'm just going to write it down on paper, f of x equals x minus 3 over 3. So let me look at what we have. Okay, so just a reminder that this notation, I just want to make sure that we remember what notation means. If you guys recall, we had that one assignment where we were kind of writing like facts about functions and then facts about the inverses. So we said like, if f inverse of 8 equals question mark, then that means that f question mark equals 8. Okay, so if we want to know what the inverse is going to equal, then we need to know when the function is going to equal 8. So what I need to do is I need to be able to solve the equation x minus 3 divided by 3 equals 8. Okay. So if you want to solve that by hand, by all means, that's what they expect you to do. But if you want to be lazy, let's go ahead and figure out how to do this on Desmos. So on Desmos, I'm going to get rid of all of these things. And I'm going to type in x minus 3 divided by 3. And then I'm going to type in 8, but I want it to graph. And so I'm going to type in y equals 8. And I want to see where these two things intersect. They intersect at 27. They intersect at 27. Okay, so what this means is that in theory, f of 27 equals 8. F of 27 should equal 8. And that should mean that f inverse of 8 equals 27. So let's just make sure that that makes sense. So let's go back here. 27 minus 3 is 24. 24 divided by 3 is 8. Okay, so that does make sense. So this is the answer. Let's make sure that that's one of the answer choices, that I have not led you astray. 27, yes, the answer is D. All right, so that is all that I had for you. Lots of solving problems on this one. So remember that if you're solving problems, if you can graph it and see where they cross, then go ahead and do that. But if you can't, you do have that slider method that you can do to like plug the numbers in and see where the two sides of the equations equal each other. And if there are some things that you are more comfortable doing on your graphing calculator, you can still use your graphing calculator. You do not have to use Desmos for every single problem. So again, this EOC is going to be calculator active. It is a computer-based exam. And so you're going to have Desmos built into the exam. You're going to be able to use your calculator as long as you have fresh batteries and bring your calculator that day, you are good to go. So just make sure that that you have all the materials that you need, and I am full supporting you with whatever whatever you have. So make sure you guys work today on Unit 3 and Unit 4, and that you check Canvas to get your answers submitted in the appropriate place. All right, and send me a message on Remind if you have any questions.